As Cindy mentioned, my name is Nicole Wolter. I am a computational data science research specialist here at SDSC, and I'm presenting on behalf of the Complex team today. At the bottom, I have a link to both those links that Cindy has in the chat. Not only will this provide you links to the slides today and the supplemental exercises for this particular presentation, but it'll also be for all the presentations that we have here through the Complex program. So just very briefly about Complex, if this is your first time joining us, Complex is an NSF training program, and it's designed to specifically focus on topics that are for non-developers or program developers. So everything that is like parallel computing concepts, Linux tools, bash scripting, security, batch computing, all these things. Basically anything that is non-programming, although what I have in this slide is a little misleading because today we are talking about scripting, which is essentially going to be a little bit of programming. So as mentioned, today's topic is Linux shell scripting. So I'm going to step back a little bit and just remind everyone what a shell is and what it does for us and what we can do with it. And then we'll focus in on kind of high level what shell scripts are in kind of a general term. And then we're going to focus in specifically on bash shell scripting. And I'll talk a little bit why we chose bash, and we'll discuss what other shells are available to you. But we'll talk about the bash scripting, and we'll talk about variables, shell functions, shell control, things like that. And at the end, we'll have some time for questions and answers. So when we developed this particular slide deck and the exercises, we assumed that folks were familiar with kind of the Linux basics. So if you've ever logged into an HPC system, then you've logged into a Linux system, or at least through the Access program. And so the basics we're kind of talking about are being able to navigate around file systems, listing files, removing files, then basic programming concepts such as loops and redirection. And that if you're going to do the exercises, that you've used one or more of the editors that are available to you on Linux systems. So with that, I'm going to ask Cindy if she can set up a quick poll and let us know if we made the correct assumption here. Again, while you're doing that, I'll give a little background with the feedback we're hoping for is, first, we want to make sure we're presenting material that is relevant to you all, and that we're presenting the material in a way that it's at the level that is needed for all the users. So looks like, all right, so it looks like the majority are familiar with Linux concepts, but there are several of you who are not, or something in that list didn't resonate with you. So I'll make sure that I step back a little bit to make sure that I catch everyone up to that slide. Thank you, Cindy. So let's get started and jump right in on kind of stepping back on what a shell is. So if you've ever logged into one of our HPC computers here at the center or through Access, you have logged into a shell. And basically that shell is the command line interpreter that has a programming language. And it's going to allow you to interact with the operating system. You can use it actively or interactively. So if you type things onto the command line, it's interactively. Today, we're going to talk about doing it interactively by writing shell scripts. It allows you to control, it allows you to run commands. You can do them synchronously or asynchronously. You can start jobs. You can run jobs in the background. There are lots of different shells out there that I'll talk about. And with the different shells, they all kind of stem from the same place, but they all have different functionalities, slightly different syntax. So you need to be aware of which shell you're in and which shells are available to you. So this is a non-comprehensive list of the shells that are available to you. And they kind of all stemmed out of this Bourne shell, which is the original Unix shell. And the Bourne shell is a great shell. It has great performance. But as with everything else in the world today, or even past or present, great things sometimes can be improved upon, and people find features that they find that are important. So these other shells evolved from them. So today specifically, we are going to be using the bash shell. But I'll discuss the bash shell a little bit more a little bit later on. So since it is important to know which shell you're in, by default, when an account is created in Linux, you get a default shell. So everyone logs in, it has a default shell. Knowing what shell you're in is kind of important, although you can run shell scripts and you can run other commands within any shell if it exists on the system. It is important to know where you exactly are. So you can find your current shell by typing the command echo $0. So $0 is a special parameter in shells. And when you type it on the command line, it's going to return the shell that you have. If you type it into a shell script, it's actually going to return the script name of what you're running. So it's useful for debugging. Another thing that's important to note is that sometimes you can tell which shell you're in simply by the prompt that it has. So when you log into a shell, there might be an arrow, there might be a $sign. Bash uses the $sign. Note that the $sign, as I kind of alluded to up above, is also a special character in Bash and some of the other scripting languages. So it's important to be aware of that distinction so that when I go through the slides or the kind of the examples later, you're not confusing the shell prompt with the special character in the shell script. So you can check all the available shells on a system one of two ways. You can either use the change shell command, which is chsh, and the listing -L, and this will show you all the shells that are on your system. If you notice on the right-hand side, I think I got that right. Yes, the right-hand side, that some of the shells seem to repeat themselves, but they're in different directories. We'll talk about that a little bit more later, but I want to point that out for you. The other way you can see all the shells that are available is you can cat the etc shells file itself. Thing to note, I think I mentioned this before already, that shell scripts can run from any shell. So you log into a shell, you can change shells from the command prompt, you can launch a new shell from the command prompt, but you do need to make sure that the shell exists on your system and that you have already told your system which shell you are using to make sure that it can interpret it properly. So why are we focusing on Bash today? Well, we're focusing on Bash because it is a really common shell that's used out there today. A lot of HPC systems currently run Linux-based operating systems, and a lot of them use Bash. Our system here at SDSC, specifically Expanse, uses Bash as the default. So what are some of the great features of Bash? The one I use all the time is the command line editing in history. So essentially it keeps a record of all the previously entered commands, and it allows you to easily recall and re-execute them. You can use the arrow up or down to go back and forth between commands, but you can also type history. It'll show you all the commands you had. In the listing, it'll have a number in front of the commands that there are, and you can do an exclamation point and that number, and it will re-execute that command. So that's the one way we can make sure that we can reuse our commands that we have. The other way is going to be to write a shell script to do that, but more on that later. The other things that are important that we can do is job control. So it allows users to run multiple commands. You can run them in the background or in the foreground. You can manage them to suspend them. You can resume them. You can terminate them. It has this really versatile scripting language and a large feature set, which allows for making good solid scripts that we can use to facilitate our workflows. And it also allows us, the other thing is it has extended facilities for shell arithmetic. So it allows us to do, I went too far. So let's go back to the versatile scripting language a little bit more. So some of the things that it allows you to do, it allows you to create aliases, it allows you to use arrays, it allows you to use brace expansion and pattern matching and conditional expressions. And then it does the shell arithmetic, which is it's a great feature. So let's talk specifically about shell scripting. This again, in the high level, we'll go into specifically Bash and its components a little bit later. So a shell script is essentially just a file. It contains a sequence of commands. comments. It's going to go through those commands and comments line by line and execute the ones that it should and not execute the ones that it's not allowed to. It's going to allow you to perform a series of actions, such navigating around in directories. You can create things, you can launch other processes. You can even launch other shell scripts within there. Basically, it's a simple button. It allows you to do anything that you can do on the command line, but you can do it programmatically. So why do people use shell scripts? Shell scripts are widely used by system administrators, widely used by program developers, but a lot of the stuff, it's essentially to avoid doing anything repetitive. And by avoid repetitive tasks, just fat finger typing, you can make errors. So automation of repetitive tasks. So some of the things that, for example, are that you can do by yourself is file management. You can clean up temporary files, you can organize directories, you can rename files. If you have a script that needs files in a certain format, you can do that. You can move files around based on certain criteria. With the cleaning up of files, this can also be done by system administrators. Essentially, on our system, we have a scratch directory, and we can write a purge script that makes sure that it cleans it up every day or every 6 months or what have you. Again, the system administrator doesn't want to manually do this every day, so writing a script, putting in a cron job will allow it to happen every day without them having to do anything, without them having to worry about typing something incorrect. It allows for backups, so automating processes of creating and storing important data, running a package manager, so system updates, check to make sure if software is up to date. It allows you also to do system administration and monitoring. This can be both for system admins, and it can also be for the security team. They can check the logs to see if unsuspecting IP addresses are coming in. Again, they don't want to be doing this manually because it's way too much time. Now the big buzzword now is with doing data mining and AI. This pertains to having huge amounts of data. So again, writing scripts that can do our ETL for us simplifies our task a lot. And I alluded to before, just this automation. At the very end, I'll talk a little about cron jobs, so we can write these scripts, but then we can also use the cron facility to schedule when these happen, how often they happen, and where they happen. So the advantages. Shell scripting is really simple for all of you, those of you who have some basic Linux knowledge. The language that you're going to use to write your shell scripts is exactly what you've been using in day-to-day whenever you've been interacting with your Linux machine. So you don't have to learn a new language for it. Very often, shell scripts are used as kind of hacks to quickly deal with something. So when we write this, it's very quick to write shell scripts because there's only one component that has to be in there. Everything else can just be your commands and can be as long and as short as you want. It's really quick because it is not a compiled program. You don't have to worry about compiling the program or formatting it in any way, shape, or form. It allows for interactive debugging. Most Linux systems have all these shells, so it's very, very portable. Depending on what shells are available, sometimes there's slight nuances, such as where the shell is available or the syntax you might have to change depending on what shells are available to you. And then again, what's really great about it is it allows you to reproduce things reliably on a very reliably. On the flip side, while it is simple, it is also simplistic. So it's not going to support really complex data structures. Actually, it doesn't have data structures at all. So there's some challenges in error handling, and it's not really suited for well suited for database tasks that require a high level of intense interaction with the database itself. So some high level guidelines is if you're if you're calling other utilities or doing like relatively little data manipulation with the database, definitely use a shell script. If it's less than 100 lines, definitely use a shell script. If you really need high performance, then you should probably go on to a compiled program. Again, with compiled programs, you can very specifically fine-tune your code to take advantage of specific architectures. You can't do that with scripting languages. The last thing is not so much a drawback as kind of a tale of caution. Very often, because it's so easy to write and because most people use them as quick, simple hacks to deal with a problem quickly, the quality of shell scripts is usually pretty poor. So the documentation isn't there, the variables might be not well defined. So if somebody gives you a shell script, again, the necessity, if it ain't broke, don't fix it. If it works for someone, they might hand it on to someone else, and then the whole lab is using the shell script that's not well documented. And, years later, someone comes back and has no idea what's going on. So to address that, we'll talk a little bit about the conventions. So there are two kind of main important things. Well, they're not important, but they are fundamental things that people should follow to kind of help with the readability, manageability, and portability of these scripts. Because it is coding essentially, it's really important to write good code, even if it's just a shell script. So the two kind of key features that are highly recommended is to use a naming scheme with it. So essentially it can have any name it wants, but if you end it with the .sh, it gives, if someone is going through a directory, it's very easy to see that this is definitely a shell script. You could be more specific and you can do a .bash if you wanted, and then people would know that it's specifically a bash script. Again, this is not required, but it's a feature that it's just good practice. The other thing has to do with readability and how you space things. It's highly recommended that you use indentation of 2 spaces and do not use tabs. So scripts can be run in 2 ways. You can either run them as executables or non-executables. If you run them as executables, you can run them without any command before it. So it's a / the script name. But you can also execute, or you can run them if you have not put execute permissions on it. So there's kind of 3 examples of, you can do source and the script name, sh in the script name, or the specific shell you're running in the script name. So essentially all a shell script is a list of Linux commands. It's just a plain text file that contains commands that run on the command line. So the first line is, I mentioned before that there's 1 line that has to be in every shell script. And so that first line is going to define what shell is going to be used. And that's going to be followed by commands and comments. So comments are identified with the hash. It's important to note that while the hash is considered a comment and it's not going to be executed by the shell itself, it is not necessarily going to be ignored. So let's talk about special comments for a little bit. So in shell scripts, special comments are essentially lines that start with a hash, but the purpose is not just for documentation. These special comments can influence how the script is going to behave. It can provide metadata to the system, or it can be interpreted by other tools or systems to modify some behavior. So 4 of kind of the most important ones. Again, the most important one is when you're running a shell script is that first line, and this is going to be called a shebang. And so it simply identifies which interpreter you're going to be using. And so I'll show there's a couple different options that you can use as a shebang, but you can use some parameters with it to identify if you want to do some debugging as well. The next, and for HPC systems, all HPC systems have these batch schedulers. So if you've been to some of our previous complex talks, you might have, where we've talked about Slurm, you've probably seen some of the batch scripts that have an SBatch in them. The batch scripts are essentially just shell scripts. But so the first line will have that shebang, and then after that, there's a series of hash SBatch. So on our system, we use Slurm. On some other systems, they use PBS. So it looks slightly different. There's also different, scheduling tools that will have different directives. But that SBatch will allow you to give directives to the system. So how many cores to use, how much memory to use, how long you should be able to run. So another thing that can be used by the or a special comment is editor hints. So for example, in BIM editor, you can configure it to give hints to the editor. So in this one, it kind of tells you how to handle tabs and how to handle indentation specifically. I'm not going to go too much into this, but it's a special comment. Oops. The last special comment is you can use with the spell check director. So this is something actually I learned new about this, but if you use spell check, it is a static analysis tool for shell scripts, which gives you lots of hints, and it'll help you debug, it'll help you write better code, it'll help you write cleaner code. And so you can actually use shell check within your script itself to pull out some and give some information. I'll talk a little bit more about shell check at the very end when I talk about debugging. So as we mentioned, that first line is pronounced shebang. It starts with the hash and then the exclamation mark, and it specifies the interpreter you're going to use. There's kind of two paths you can go down. You can either use the environment command, and that's going to display the environment that you're in and pull out the command that you're asking for. In this case, it's looking for bash. So, excuse me. The advantage is that it's always going to search for the default version of the interpreter in the current environment. The disadvantage is that it's not going to support multiple parameters. So where I mentioned before that you could add in some parameters to do some debugging, when you're using the environment, you can't use that. On the other hand, you can use an absolute path. This is kind of added security. You know exactly what you're using. However, on different systems, that path might be different. So you could end up having to go and modify, and by using the chain shell, you can find which path you want to use. The other thing I wanted to mention is that I use two different types of path here. So you could use the environment in the bin environment or the user bin environment. So user bin, they're slightly different. So user bin is a utility that runs a program in a modified environment. So it's used without any environment variables or modifications. So, and its primary purpose in this context is locate the specific program. So the difference between the two things now is like a little bit of historical context. The bin SH is basically the path that's designed for essential system utilities that are required for a system at boot time. So when the EMV might not yet be loaded, it will still be able to find the bin bash. The interesting thing to note is that bin bash and user bin bash are generally symbolic links that are pointing to the same place. So you're essentially using the same executable. So let's talk a little bit about the other comments. So we talked about special comments. Now let's just talk about the normal comments to make sure that our code is readable and that other people can utilize it and modify it in the future if needed. So all lines that begin with the hash are comments, and they will not be executed. Comments they can stand alone on a line. They can follow a command on a line. They can follow a bunch of white space on a line. But what they cannot do is follow a command unless you put a semicolon. So a space and a semicolon are actually important. Everything, while it is simplistic, shell scripts are simplistic, everything sort of has meaning. So if in the case up above where you have all the spaces in the list, it knows that there's nothing there, and it will deal with the comment because the comment indicates something to it. You can use quoted or escaped hash in an echo statement, and this is not going to be a comment. You can also use it in parameter substitutions and base conversions. So so variables in Bash. In every programming language, you need to have variables. Variables let you store data. They can be used to read, access, and manipulate data in your script. In shell scripts, you can store numbers, characters, and/or strings. Important to note that there are no data types in Bash, which means that the operators that you use on those variables are going to indicate how the variables are going to be handled and interpreted. Back to some conventions. So variable names can only contain uppercase, lowercase, digits, numbers, and underscores, but you cannot start a variable name with an underscore. Variables are case sensitive, so Nicole with a capital N, Nicole with a lowercase n are completely different, and spaces are not allowed. As I mentioned, spaces in shell script are interpreted as something, and I'll give you an example, I think in a few slides from now. There are some predefined keywords in scripts that we'll use for flow control, like if, else, etc., and those cannot be used as a variable name. And in shell scripts, there is the concept of global and local variables. So let's talk about the special parameters first. I mentioned before when we talked about returning the shell using the $sign. So special parameters are special system managed variables that store information about a shell state, such as command line arguments. They contain exit status, they contain process IDs, and you cannot assign values to these parameters directly. It treats them special. They can only be referenced. You can't assign anything to them, and they kind of point to positional characters, special characters, command line arguments, and exported variables. So again, this is not a comprehensive list of everything that's out here, but here are some of the special variables that you have access to. The first three are very useful in kind of debugging. The first will tell you how many command line parameters were passed. When we start scripting, you'll see that you can input parameters simply by following the shell script name with various parameters to ensure that you're getting the right amount of parameters and you don't have a space. This can be very helpful. The $@ will give you all the actual parameters that were passed to the script. So not only now you know how many were passed and what exactly was passed. And the $? is the exit status of the last process. Again, a little bit of help in debugging. The next three are very useful if you need to do a naming scheme for files. So very often we will use the process ID, the username, and the host name in our output files or error files to differentiate which file is being used. Very often this is used in the Slurm scheduler things, so we can put the job ID in there so we know exactly when something was run and how it was run. If you don't use any kind of variables in names, it could be that your files get overwritten. Some other interesting or useful things are $seconds. Basically, if you want to do any performance evaluation of how your script is running. I know when I first started writing Linux command or shell scripts, we had to do some little test tools. And one of the things was to create something and we needed a random number. So shells will easily pull out a random number for you. And also for debugging, you can use the line no. So when you're running things, you can report which line you're on that is giving a certain output. So variables can be characters, digits, numbers, and strings. And spaces are not allowed between the variables and the values. And the reason is because that space is interpreted as something. So if we're creating a variable, you do the variable name. equal to the value of what that variable be. Remember that everything is case sensitive, so making easy variable names that and not too complicated is always good, and make sure you take are aware of your capitalization. You can always change a variable value by simply reassigning it below after it's been already assigned. The dollar before the variable name is how you retrieve a variable name. So this is again where I want to caution between the using the special character and the command prompt for the shell. So below, I just have some examples that show kind of where some pitfalls are. So string 1 is equal to Nicole. I can echo the string and it's Nicole. However, if I do string 1 space equals Nicole, it gives me the response of string 1 command not found, because essentially string 1 is not a command. So it doesn't know what to do with that. So on the second one, we change where the space is equal to nickel. So in this case, string 1 is equal to a space and then Nicole, it doesn't know what to do with that. But as you can see lower down, you can put a space between, you can do a series of assigning variable names, and it will recognize all of them. So if we assign string 1 to Nicole, put a space, string 2 to Ben, string 2, if we echo string 2, we'll get the correct answer. There are local and global variables in Bash. By default, everything is considered global. The only time it is local is if you specify it to be local, and you can specify it to be local within a shell or within a function. So for those of you who are not aware of programming stuff, the scope in a program or a script is the region where the variables have their existence. So normally if a variable is declared inside a function, it's generally going to be local variable to that function. If it's declared outside, then it's going to be a global variable. So this is not how it works in Bash or in the scripting language. So here's just a quick example. I start my shell script with our shebang. I set a variable to var1 equals strawberry. Because I didn't define it as local, it's going to be a global variable. And then I create a function. In the function, I will create one local variable. var2 is banana. Because it's specified as local, it will only be known within this function right here. We also do one more global variable just to prove our point within the function to show that that this is going to be a global variable. Then we quickly type inside the function, we name our 2 fruits that are inside the function, one that is outside, so we see that the function sees the variable that was defined outside the function, and also the local variable that's inside the function. So then, after we're done outside the function, we try and echo the same thing. So we echo the first fruit, which was outside the function, that comes back, and then we try and echo the 2 variables that were inside the function. So as we can see, outside the function, we still get strawberry because that was global, but the second fruit is going to be blank because it's ill-defined. Because we're outside the function, it doesn't have any knowledge of what that's supposed to be. And the third fruit, again, because it was global within the function, it's global outside the function as well. There's this concept of scope so while everything is global, there are still areas where just because you write because it's available in your current shell doesn't mean it's going to be available in any other shell that you're in. So there's environment scope, which is available in your current shell, any immediate subprocess or subshells. You should note that when you run a script is essentially a subprocess that you're starting. So anything you do in that top level will not be known in your script itself, so you will have to specify it in there. You can do shell scope, which means it's available to your current shell and all subshells. You can do function scope. Again, that'll be within your script, which is which is the current shell. And then within the current shell, you can also, within the function itself, define local. There's command scope. So if you just want to do one line stuff, you can define a variable and then the command afterwards. And so it's going to be available to it itself and any immediate subcommand or subprocess. And then finally, the subshell scope. So if I open a, if I'm in a shell, I open another shell and I define a variable. For any shells below that, it will be available, but it's not going to leak back up to that top shell where I started beforehand. I guess this might be a space where I could stop and ask if there's any questions, Cindy.
None at this time.
Okay, great. So let's talk about variable operators. We mentioned that our variables do not have data types, so how they are interpreted by the is going to be based on the operations that are put on them. We can have arithmetic operations and we can have string operations. The arithmetic operations can contain things such as arrays and command substitution. The strings will allow you to transform variables. You can do string substitution or string extraction. You can also check the length of a string using these things. So let's talk about the arithmetic operations first. So the format for doing any arithmetic is $, 2 open quotes, 2 close quotes, and the expression in between. The operators that are supported by bash are addition, subtraction, multiplication, division, exponential, and modulus. One thing to note that by default, they only work on integers. So if you want to do decimal calculations or floating point arithmetic, you need to just use the basic calculator. And this will allow you to do more advanced math and take advantage of like advanced math functions that they have. So like they'll have square root, they can do sine, cosine, log, stuff like that. So let's just look at a couple examples and I'll kind of hit home about the integers. So in this example, we just use variable num1, num2, and then we will do sum, we will sum them, we will subtract them, we will multiply them, we will divide them without the basic calculator, and then we'll divide them with the basic calculator. By default, the basic calculator will format everything to have 2 decimal places. This can be modified. So you can format whatever you want when you're using the basic calculator. So it's fairly straightforward, add, subtract. On the flip side, we can use operators for string and command substitutions. So this can allow us to take the input or output of one command or program and save it as the value of the variable. So we mentioned or with variables, if it is just one word, you don't need to use quotes. However, if it's longer than one word, you have to put quotes around to make sure that it captures everything in it. So our first example here, we're going to set the variable name to be equal to the best of the best. And then we're going to do some substring extraction from it. So with the curly brackets, we can echo from name the first 4 characters that are denoted by the position 0 to 4. So if on the right hand side here, if with the echo we're going to see is that we're just going to get best out of that. I have an example here of both where we use the quotes and we don't use the quotes. So you can see that the first name Wiley, the last name is Coyote, that you can use quotes or not if it's a single string with a single word with no spaces in between or special characters. So if I want to concatenate these two strings, I just need to use the $curly braces, the first name. Then I'm using double quotes to literally put in one space in between the first and last name. The other thing that I can do is, with strings is I can do command substitution. So by using the single quotes around it, I can put any command in there that I put in the command line. I can even do complex commands by piping one command into the other and returning it into the variable name. So in this case, I'm listing everything that is in the user directory, and then I'm doing a word count on the number of lines that are in there. So this final thing is just giving me the number of lines that are currently in that were currently in the user directory when I ran this command. So I think I had this. No, it wasn't this one. So one of my slides, I do have it where one of the quotes, because before I created all these, I tested to make sure that my syntax was correct and I had everything correct. So I copied and pasted from the command line and put it in. Sometimes when you copy and paste things, it will give you weird stuff will happen. And in shell scripts, it is one of those cases where that can happen. So Linux has two types of quotes. There's the single quotes, which preserve the literal meaning of everything inside the quotes. And then there's a double quotes. So this is going to preserve everything inside the meaning, but it's also going to ignore our special characters so that we can use variables and the like. Very often it is recommended to use the double quotes and this will prevent globbing and word splitting, even if you're not using special characters. So in this example, we set two variables. var1 is ABC, var2 is DEF. If we echo var1 plus var2 in single quotes, it is going to literally return what I have between those quotes. However, when I use the double quotes, it's going to interpret those special characters, the $sign for both var1 and var2, and actually return the actual what they were defined as. So again, be careful with the copy and paste. Sometimes it'll create another type of quote, which will throw an error for you. There's also backticks. So backticks are completely different, and they capture the input, the output of a command. So for me, with backticks, who am I will respond who the current user is who is typing the command. Date, it will return the current date. So when I ran this, again, it returned my username Nicole and the current date. So shell scripts can take one or more inputs. They can produce 0 or more outputs. It can also produce errors for you. Scripts can take output directly from the terminal or redirect it to a new file or append to an existing file. The greater than notation is used to redirect to standard out. The double arrow in this case appends, so redirects to standard out as well. But the difference is that it won't overwrite a file. It will append the file to the end of the next one. So let me go a little bit more in depth in the redirection options we have. So again, there's 3 types of files that we have. We have standard in, standard out, and standard error. So you can capture the output of the file, the command, a program, script, or code block by sending it as input to another file, program, or command, or a script even. So the greater than will redirect the output from whatever into a file. If the file doesn't exist, it's going to create it. Otherwise, it's going to overwrite the file that was already there. Using the double caret, it will make sure that you don't overwrite your file, but you could get long, ugly files. The pipe command is great because it allows you to chain commands together. So you can do one command, use a pipe, chain it into the next command, and you can do any number of series, and you can make some pretty complex commands doing this. On the flip side, we did redirecting out. Now, if we want to pull in some information from a file, we can use the less than. We can also make sure that we get our standard out and standard error together, and that's by using the ampersand greater than. The final thing, the triple less than, is a redirection operator that stands for the here string, and it takes a single string of text and passes it to a command and standard output. So I will give you an example of that a little bit later on. Command line arguments. So shell scripts can accept command line arguments. Generally, so you see the usage up there, counter .sh, and then in the square brackets is file. So that is what your input is going to be. So for this one, if there's only one file in there, the $1 will return that one file. Note that you can have any amount of command line arguments that you want, but you can only go up to 9 if you don't have brackets. Once you go past 9, you're going to have to put it in curly braces. So the next one will be $curly brace 10, close curly brace. So in this command, I actually have 2 slides that kind of show the same thing, but in different formats to show kind of an easy way and a hard way of doing things. So in this script, we are basically returning variables for the number of characters in a file, the number of words in the file, and the number of lines in a file. So in the curly braces, the command that I'm doing is I'm doing a word count on the file, and I'm piping that into cut D, which splits the output on spaces, and then we print just the first field. So we can see that in the first, I've run the script 2 times on file 1 and file 2. In the first file, it has 180 characters, 36 words, 9 lines, and the second one is 100 characters, 20 lines, and 20 words, and 5 lines. But we can do that much simpler by using the backticks for the command. And basically, we're just using the word count -C, and we're redirecting the input from $1 into that file. So this is much cleaner or much simpler way of doing the exact same thing. So functions are a great tool. It now allows you to group reusable code blocks within a script. So basically, it's going to perform some task, and you can call it multiple times within that script. Functions are nice because they allow you to pass arguments to them. The arguments are going to be passed to a function by listing them after the function's name, just the way we did with the script. And they're going to be accessed in the same way, again, using the $, and the number of the argument being passed. Again, I just want to remind the idea about variable scope, that everything in this function is going to be global, but it can be passed down, but it can't be passed back up outside of the script itself. So let's talk about looping and branching. Looping and branching are control flow mechanisms. They allow you to reuse code block by enabling the repeated execution of code for certain constructs. There's 3 different types of loops that we can do in bash shell scripting. We can use for, while, and until. For is going to iterate over some sequence of items. While is going to repeat as long as the condition is true. Until is going to repeat as long as the condition is false. We can also use branching, which allows you to use conditionals to create your workflow. There's 2 branching techniques we can use, or the types of branching we can do. We can use the if branching or case. So if is going to execute code conditionally, again using conditional statements, and case is going to provide a way to actually do pattern matching and run code based on if you match that pattern. So let's look at for loops first. It allows you to iterate over items in a list. You can define those lists in lots of ways. It can include a white space separated list of items. So you can do file 1, file 2, file 3. It can do wildcard expansion. So the first item or the first example we have here is for file name in file star.txt. So this is a wildcard expansion. So for any file that starts with file, has something there, .text, it will go through the whole list of it. We can also do a range of numbers based on a command that we do. So ls-1 lists all the lines in the file one at a time. So it'll go through all of them. Every single line that's listed in there, will list them. And sorry, ls-1 file.text will list each file in per line. We'll list one file per line, and then we'll go through all of them until it completes. We can also use expansion with the curly brackets. So file, and this will do file 1.txt, file 2.txt, all the way up to 5. And the last example we had was the spaces. You can do file 1, and you can do any number of parameters with spaces in between. You can also iterate over a range, iterate over a range of numbers, and this is going to be our for loop. So you can either use a sequence command or you can use a curly bracket notation. Within these, you can also define stride. Depending on which notation you're using, the stride is going to be in a different position. So for the simple example, using sequence, we just want to, for sequence in 1 to 3, and this will cat the contents of file 1, 2, 3, and it will concatenate them into file, the start out file. Using the curly bracket notation is going to do the exact same thing. Essentially, it's going to loop 3 times. Again, doing the exact same thing. However, you might want to be more complicated. So in the second, for the sequence, your stride is going to be the second comment. So in this second one, we are starting from 10, and we're going to drop down by 2 each time, and then we're going to stop at 0. So again, the difference is the sequence is the stride is a second. In the curly brackets, the stride is going to be the third parameter. Our third type of loop is the while loop. So it's going to loop, it's going to check for a condition and loop while the condition remains true. So in this particular example, we want to loop for 3 times. But to do that, we need to provide a counter, or else it's going to become an infinite loop. So we will designate where the counter starts. So outside of the loop, so I is equal to 1. Then we will start our while loop. While it's 1, it's going to do something, and then we're going to increment it each time. So it'll go up to 3. When it hits 3, it will fall out of that loop. Branching and decision making. So decision making is going to use one or more conditions for the execution of a code block. If the conditions are satisfied, then the code block is going to get executed. If the condition is not satisfied, it's going to drop into the next condition potentially, or drop out of the loop altogether. So we can use expressions for this. The expressions are going to produce Boolean results, either true or false. What those are what those expressions are, or what we're going to call conditions or conditionals. So there's 2 types of decision-making statements that are used within the shell scripting. You can use the if, else if, else if, or the case statement. So let's look a little closer at the if statement. So a simple if construct, the shell is very quick, is really sensitive about the white space that's required around the brackets. The bracket is essentially the square brackets are the conditional statement. So if bracket colon, then is going to be kind of the format we use. In if else, else if, you can have as many conditional statements as you would like. Each else if construct is going to be tested, and it's followed by a semicolon and the then statement. You can finish this out with an else statement, which means that everything else will just fall through into it. All the if statements you'll know that your loop is completed by the inverted if. Similarly for the case statement, it starts with the case, the expression that you're looking for. It was going to close with the inverted case word. It's going to compare to a specific value in the list. So you can look for specific patterns. So in this example, I have specifically used countries. In the patterns, you can use pipe, you can use ors. Two types of you can use or statements to make it more readable. You can use case statements instead of if statements to help make your scripts more readable and easier to maintain. The case keyword initiates the statement, followed by the expressions to be evaluated, followed by the in statement. So each pattern is designated as a pattern with that closed parentheses, and that represents a potential match for the expression's value. Oh, I am out of time. It ends with so each command ends with a double semicolon, and it terminates the command list. If you use a star, it acts as a default case, executing other pattern matches. And again, it closes with case inverted. Shell operations. In shell scripting, we make decisions by doing comparisons on strings, partial strings, or numeric values. With string comparisons, we use logical operators to evaluate. With numeric, we use arithmetic operators. These are the list of the operators that we can use. In numerical comparisons, the values can be compared using less than, equal to, greater than, equal to, or equal to. In this example, we're just going to test if two numbers are equal to each other. The usage is the name of the script and the first number and the second number. Those brackets shouldn't be used if you're running the script. Again, since these are numbers, these commands only work on integer expressions. So if you want to use a floating point, we're going to have to use echo statements and use commands instead of just these simple conditional statements. String comparisons can be compared using the equal to, the not equal to, the greater than, less than. A thing to note with string comparisons is that they do things with for ASCII order. So that means that 1, 2, 3 is going to be less than 4, 5. I'm sorry, I'm hurrying up a little bit because I know I'm very out of time. The last thing to kind of with the conditional statements, one of the good reason to use it is to test for existing files. You can use these to test if a file exists. You can test what type of file it is. You can also what type of file it is, or if it's directory. Here's just an example of check if the file exists. If it exists, then you can check if the file is a regular file, or you can check if it's directory. Debugging. I mentioned at the beginning that there's a couple ways of doing debugging, and you can actually do it has built-in debugging with it. So you can debug the whole script on the command line. You can also put it in the shebang. So command line, if you don't put it in, when you run the script, you put the -x in there, and that'll allow it to print all the command traces before executing the commands. If you don't want to put it in the command line, you can actually put it in your shebang statement, where you do a -x in that first line. But if you don't want to do the whole script, you say you have a longer script and you know just where your problem is, you can also do it specifically in a specific line. So you can set something, you can do some commands, and then you can unset it. The other way you can do debugging is, again, the spell check. So spell check, it's actually a pretty cool tool. You can download it to use it directly on your in your shell. But you can also, there's this link here that you can copy and paste it into the link, and it'll give you all the output on the internet. Automation is very helpful. So again, one of the great things about shell scripting is that you don't have to do everything every time, print everything out, avoid things, and you don't even have to be awake to do these things. So in Unix, we have a cron tab, and that can dictate when you run something. You can limit it to what minute it runs, what hour it runs, the day of the month, the month that you're running it, the day of the week. So for example, we have our system admins here manage our accounting using the cron tab. So we update our ACL file, or to let us know who can run on the system every 4 hours. We update users on the system every hour. We send usage notification to our to access overnight. So all this can be done. They're all written in Bash. They're all written in scripts, and they're all run by putting an item in the cron. So we went through a lot of stuff today, and I apologize. I went rather quick, and I stumbled a little bit on some areas, so I didn't get to go into depth in some of the other areas. But nowadays, you all have an easy button, and it's this whole using the LLMs, ChatGPT, Copilot. You can simply ask it, write me a bash script that prints hello world. But your time here with me was not wasted, because you do not know what you can ask for until you know what's available out there. So being specific, and also it's always good to remember that the large language models do sometimes have mistakes. So being able to fix things and to know what you're looking at, and that is actually doing what you expect it to do, is important. In summary, scripting is great for automation. It's a very portable programming tool. There's a lot of flexibility to it. Everyone who has access to a Unix system has access to this. You don't need to pay for it extra or anything. Integration is really good. You can integrate it with other tools and applications, such as Swarm Scheduler. You can also call other tools from it. There's some handy debugging tools that come along with this. So in summary, shell scripting is a great tool to have. It simplifies your life significantly. It's great for being an effective user in cyber infrastructure, because again, the workflows that we have nowadays get more and more complex, and remembering things that you did in the past is always tricky. So writing a nice little script that does it for you, documents the process, so it allows you to reproduce it at a later time. This tutorial, again, was kind of high level and gave you a quick and dirty of what's all out there. I strongly encourage you to check it out. Scripting is actually really fun. And it's really cool when things work and you can say, wow, I did that. Here are a couple more, some tools where you can go a little deeper and explore further. This is just for your reference, a cheat sheet of some of the stuff we talked about today. And here's some additional references.